Hey guys, this is Zal. This is the second part of the video to help you out with part B of the exam, which will ask you to set up continual shocks in the Solow model. Now, first of all, what do I mean by these continual shocks? Well, these are these shocks that I showed you in class on Friday. Okay, you can see what's happening now, once we've set up these continual shocks, is that the entire economy will evolve dynamically over time. Okay, so you can see, for example, here, I've set up continual technology shocks. Okay, so technology, the size of the technology shock is 0 in the first 20 periods, just like it was before. Okay, but then subsequent to that, instead of technology just going to 1 and then dying back down, the value of the technology shock is going to change continuously. Okay, sometimes it's going to be positive, sometimes it's going to be negative, and then the actual level of technology in the economy will be equal to the previous value, okay, plus the value of the shock times some persistence parameter that I will describe in a little bit. Okay, and so we have these continual shocks starting at period 20, okay, and then that means the level of technology in the economy is continually evolving and sort of oscillating as a function of time, and then that's going to drive these other patterns in our model. Okay, and so you can see here is the capital stack jittering around, and here are all of these other model variables jittering around. Okay, this is designed to be a little bit more similar to the actual behavior of the economy as a function of time. As you guys know, the economy undergoes periodic fluctuations. Sometimes it's up, sometimes it's down, and these are based on sort of a variety of different types of events. You know, shocks to the price of oil, changes in the government policy, and so we'll be able to sort of see those types of business cycle-like patterns, okay, at least hopefully, when we set up this model. Okay, this is essentially a very simple business cycle model. Okay, so how do we set this up? So I'm going to go over here to the student version, okay, and you'll see that there is a sheet here called Solow with continual shocks starting point. Okay, and that's where you want to start off with. And what this starting point is it's essentially exactly what you set up. Okay, it's exactly what you set up in part A of the model, except I've gone ahead and I've deleted everything starting from row 21. Okay, aside from that change, aside from deleting everything beyond period 21, okay, there's absolutely no difference between what you see here and what you set up yourself earlier. Okay, now, because we've already sort of set up all of this math over here, okay, the only thing that we have to add now are we have to add these random shocks, and then we have to tell technology to take these random shocks into account in the right way. Okay. So let's go ahead and insert the random shocks first. Okay, first of all, how do we insert a random number? Well, I have the formula here on the take-home exam. Okay, so in order to put in a formula for the random shock, we're going to draw numbers, random numbers, from a normal distribution. Okay, so this function right here, norm inverse of rand, okay, this kind of funky-looking function right here, will draw some random numbers from a normal distribution. Okay, and then to control the actual size of the shocks, I have a parameter here. Okay, you can see here I've added some new parameters that are going to govern our shocks. And this first row here, this shock amplitude, okay, is going to control the size of the shock. Okay, so let's go ahead and let's code this in. So I'm going to copy this part over here, the norm inverse formula. I'm going to copy that. Okay, I'm going to go back to my sheet, go to the technology shock size, and then I'm going to put that in. Okay, now I don't want just that. I want to multiply by the amplitude of the corresponding shock. So what I want to do is I want to say it's equal to the technology shock amplitude here, this number, okay, and I want to lock that cell reference. It's not letting me insert the dollar signs. Okay, I'm going to manually insert the dollar signs, and then I'm going to multiply by this funky looking norm inverse function. Okay, and you should get some number there. And what you'll find is that every time you make some other change to the spreadsheet, like let's say I just randomly type a 2 in here, okay, every time you make some change to the spreadsheet, except Google Sheets will draw a new random number. That's what this function does. It just randomly draws numbers from the uniform distribution, or from the normal distribution. Okay? Okay, now I want to set up the same thing over here. Okay, so I want to say that this savings shock size is equal to the shock amplitude of the savings rate. Lock that cell. Oops. Lock that cell reference. Okay, times this funky looking random formula. And then I want to say that the size of the depreciation rate shock is equal to this guy, depreciation rate shock amplitude, times this funky looking random formula. Okay? And then once again, I want to go all the way down to row 600, put a placeholder down here. Okay? And then I want to fill this, formula all the way down. Okay, you can see it also filled down the color. Okay, if you want to set the color back to what it was before, just go ahead and select all of those cells, and then let's set the color. Just say reset. Okay, that'll set the color back to what it was before. Okay, so now you'll notice, okay, right now in column I, in this technology shock column, okay, I have shocks. But in these other two columns, I don't have any shocks. It's all zeros, right? And the reason for that, I don't know what's wrong with this one. Oh, whoops. Okay, you can see here I forgot to lock this cell reference. Okay, I want to lock the cell reference. Okay, and then I want to update that down again. Okay, and set it to the right color. Okay, sorry about that. Okay, so you can see right now, okay, we only have technology shocks. The shocks for these other two columns are turned off. Well, that's because we've set the amplitude here to 0. Okay, so if I were to change the amplitude here to 0.1, you can see if I change the savings rate amplitude to 0.1, we start getting savings rate shocks. And if I change the depreciation amplitude to 0.1, we start getting depreciation rate shocks as well. Okay, now for now, I don't want to deal with any of those. I'm just going to set the size of those shocks to 0. I only want to deal with my technology shock. Okay, okay. Now the last step really is to put in the formula that governs technology. Okay, and so essentially what we want to do is we want to say that technology is going to depend on the size of the shock, but it's also going to inherit a certain percentage of its previous value. Okay, and so that technology isn't just going to swing around randomly. It's going to inherit a certain fraction of its previous value, but then we're going to add on this random component. Okay, and the formula that technology and these other model parameters are going to follow, okay, is this formula right here. You might be looking at this formula and saying, okay, well, this looks rather cryptic. Don't worry, it's not so bad. All I'm saying here is that technology in next period, in period t plus 1, is going to be equal to a certain fraction of its value this period. That's this term here, and this theta here, or this this row, is the fraction that we're going to inherit from the previous period. Okay, so it's equal to this fraction times the previous period's technology plus the random shock, and then plus this constant term. You don't have to worry about this constant term. I've already set up this constant term for you. Okay, so basically what we're going to do is we're going to plug this formula into Excel. Okay, next period's technology is equal to a constant term plus a certain fraction of this period's technology plus the size of the random shock. Okay, so let's go over here. Let's go back over here. Okay, this constant term I've already programmed in automatically. Don't edit this. Okay, and then this persistence parameter, what percentage of the previous technology is inherited in the next period, I've already coded in here. So all we need to do is cell reference this group of parameters here. Okay, so what I'm going to do is I'm going to say, okay, this is equal to technology in period 21 is equal to this constant, okay, corresponding to technology, plus this persistence parameter, 0.9, times the previous value of technology, plus the value of this random shock that we've just specified. Okay, so again, that's the constant term plus the persistence parameter times the previous value of technology. Okay, oops, not times, but plus the value of the shock. Okay, I'll do that for these other columns as well. Okay, so the value of the savings rate is going to be equal to this AR1 constant term plus this persistence parameter for the savings rate times the previous value of the savings rate plus the size of the shock. Okay, and then same thing here. The depreciation rate is going to be equal to a constant plus the persistence parameter times the previous value plus the size of the shock. Okay. Now, we're not quite done yet. There's one final thing that I have to do, which is to lock these cell references that refer to this table. Okay, so I want to lock this AR1 constant term cell reference. I want to lock the persistence cell reference. Okay, and I'm going to do that for all of the cells. Lock the reference, the constant term, the persistence, lock constant term, and the persistence. Okay. Finally, I'm just going to double click this square, and I'm going to have the model update all the way down. Okay, and let's reset these colors. It's kind of annoying. Reset these colors. Okay, and so if you've done this correctly, okay, what you should see is some kind of pattern over here like this. Okay, the economy is basically now fluctuating as a function of time because of the fact that this technology shock is being imposed every period. Okay, now you want to sort of play around with it to check that you've specified everything correctly. So for example, if I set the shock amplitude here for technology to 0, okay, what that ought to do is it ought to turn off the technology shock. And you can see that's what happens if we turn off the size of the shock. Okay, the size of the shock is 0, technology is 1 every period. Well, the economy immediately falls back into the steady state. So you want to try doing that and try turning on these other shocks gradually, okay, and seeing that basically that you recover these fluctuations in the economy, and that the corresponding column here is the one being affected. Okay, so here's that savings rate shock. You can see that technology is still staying the same, depreciation is still staying the same, but these two columns or savings rates are being affected. Okay, and same thing for the depreciation rate. I just want to make sure that, oops, I don't want it to be minus 0.1, okay, to be 0.1, okay, and you can see that, okay, good, it seems like it's working. Okay, so that's pretty much it in terms of setting up these continual shocks. Okay, the exam is going to ask you to set up these shocks and then try changing the amplitudes, try changing the persistence parameters, and having a look at what kinds of changes you observe in the model. Okay, thanks for watching.